Okay, unit review here. You've done this before. Simplify this expression completely. So we have 5 times x, 5 times m to the 6th power, and then a second power times m to the 3rd. So it's all timesing with exponents. So that's when you want to make your 3 lines, okay? And remember what this means. So everything starts on top if there's no line there. So you got 5 times m times another m. But I don't write times m twice, I just add to the first m. So the 5's power, we have a 1 power, but that's in parentheses, so we have to take 1 times 2, and that's 5 to the 2nd. There's got to be 2m, so I take the m that's first, and that's a 6, but it's in parentheses, so 6 times 2 is 12, and then we need to add the 3. Then 12 plus 3 is 15. Now the second line is to play the little switch stay game. Okay, so I have these 2 exponents. That's positive, so that's a stay. So 5 stays on the top. And the power of 15, that's positive, that's a stay. So they both stay. Remember, if it's negative, you switch it to the other side of the line so you can drop the negative. Okay, now we can simplify 5 to the 2nd. That'd be 5 times 5, and that equals 25. So we have 25 times m to the 15th power. Okay. Number 2, we have 2 times x in a parentheses, and then that negative 4th power is outside the parentheses, waiting to be distributed to whatever exponents are inside. So it's times with exponents, multiplication. So we have 2 times x, and then 2 to the 1. 1 times negative 4 is negative 4, and then x to the 1. 1 times negative 4 is negative 4. Okay, now this negative 4, that means we need to switch the 2. It's on top, so we move it to the bottom, and then we drop the negative from the 4, and it's now 4. And this is also a switch, so the x moves from the top to the bottom to the other side of the dividing line where it becomes a 4. Now, if we have an empty top, we need to put a 1, okay, because you can't have a denominator, there has to be a numerator. So you have a 1, and then 2 to the 4th, that's 2 times 2 times 2 times 2, and that equals 16. So we put a 6, remember 2 to the 4th there, so we replace it with 16 in the same spot. And x to the 4th power. Okay, number 3. So if I have 2 fractions multiplied, really it can just be simplified into 1. So we have 2 to the 3rd, and then 3 times x to the 4th, then to the 4th. Now bottom we have x to the 2nd times y to the 2nd. So again, it's just all multiplication division. So we have 3 lines. So we have a 2, a factor base of 3, and a factor base of x. These little circled numbers are powers. Now bottom we have an x times a y. Okay. So 2 to the 1, now it's in parentheses, so 1 times 3 is 3. Another 3 to the 1, that's in parentheses, 1 times 4 is 4, and then the x, 4 times 4 is 16. Now down the bottom we have x to the 2, but that's still in parentheses, so we have to take 2 times 3, and that's 6. Then on the y, 2 times 4, that's 8. Now, when you have things on the bottom over here, you need to see if you can cancel them, cross them off by dividing. So you have an x on bottom, you have an x right here on top. So what we can do is take that 6 and subtract it from 16, and then I can do that. So you're dividing the common bases. Okay, 16 minus 6 is 10. Remember, when you want to get something off the bottom, you find a base like it on top and you minus, so that's 10. Now there's no y on top to take, so that y stays down here. So now 2 to the 3rd, that's a stay, because it's positive. I think all these are stay. 3 to the 4th, that's a stay. So it's on top, it stays on top. X to the 10th, that's a positive, so that's a stay. It's on top, it stays on top. Now bottom y to the 8th, that's a stay, so if it's on bottom, it stays on the bottom. Okay, now on top, what can you simplify? Well, 2 to the 3rd, that'd be 2 times 2 times 2, that'd be 8. 3 to the 4th we can simplify, that'd be 3 times 3 times 3 times 3, and that equals 81. Now the variables can't simplify, but we do need to multiply the 8 by the 81. Okay. So 8 times 81 is going to be 648. So we have 648 times x to the 10th divided by y to the 8th. Okay, number 4. 2 times e negative 4th times g to the 5th. Now on bottom we have e to the 5th times g to the negative 3rd. So again, it's all multiplication divisions. You want to set up your lines. So on top you have 2 times e times g. Now on bottom you have e times g. You don't add the e's because you got one on top, one on bottom. Same with the g's. Okay, so 2 to the 1, but that's in parentheses. 1 times negative 4 is negative 4. Now the e, 1 times negative 4 is negative 4, and then the g is to the 5th, but it's not in parentheses, so we just bring the 5 down. Now on bottom we have e to the 5th, but that's not in parentheses, so it just remains e to the 5th, and the same with the negative 3. Now, you need to see if you can cancel anything on the bottom. So I have e on bottom and I have it on top. So I just take this 5 and subtract 5 from the negative 4 that's up there. Negative 4 minus 5 is negative 9. Okay. Now likewise the g, there's a g on top. So what I do is I subtract the negative 3 from 5. Now that's actually 8, because remember minus negative is plus plus. So 5 plus plus 3 is 8. Okay. Negative 4. So there we have it. Everything's off the bottom. I was able to cross it all out. So that's a switch. The 2 is. So then the 4 becomes positive. E to the negative 9, that's a switch. So we move e to the bottom, the other side of the dividing line, where it becomes positive. And then g to the 8, that's a stay. So it stays on top. Okay, so we have g to the 8th on top. Nothing we can do about that. On bottom, 2 to the 4th, that's 2 times 2 times 2 times 2, and that equals 16 times e to the 9th. Okay, now simplify each expression. Write each answer in scientific notation. This right here you need to look at. Left is positive, right's negative. So you have 7 times 10 to the 5th times 6.3 times 10 to the 6th. What you want to do first is reorganize these parentheses so you can take the 7 times the 6.3. And then the 10 to the 5th times the 10 to the 6th. So I multiply the 7 and the 6.3, 44.1. Then to multiply my base 10s, put a times sign. You got 10 and you add the 5 and the 6. You can put a dot or a times, it doesn't matter. And that's 11. Okay, so now it says you have to have the answer in scientific notation, but you see, scientific notation, you have to find the first number that's not 0 going this way, and we have a 4. The decimal needs to be between that 4 I just marked and the 4 after it. So you need to move the decimal so it's here. Okay. So you moved it 1 time and you moved it left. So that's plus 1. So the answer is 4.41 times 10 to the 12th power. Okay. Now division's very similar. Okay. Division, we divide these. Okay. So 2.4 divided by 3 is 0.8 times. Now to divide the base 10s, you take, again, you subtract that negative 5. And 8 minus negative 5 is the same as 8 plus plus 5, which is 13. Okay, so now you start here and you got to find your first number going this way that isn't 0. That's 0. So right here. So to put a number after it, you put a 0, and you need to move the decimal so it's between the 8 and the 0. So you have to move it once to the right. Okay. So I put 1 next to the 13. Right means minus. Okay. So it's 8.0 times 10 to the 12th power. So be careful on those. Now next you get the graphs. Okay. y equals 2 times 1/4 to the power of x. So this is an exponential graph. We don't do the MB stuff. It makes like those hooks. Okay. So the best way to do this is to create an XY input-output table. So our inputs, we can pick anything. Just start with 0 in the middle and just go 2 higher and 2 lower. Now down here is where you're going to show your work. You don't do anything on that graph. So what you're going to do is circle the x, the base. This 2, you times all your outputs at the end by 2. Okay, so you got 1/4, put it in parentheses, just write that 5 times. You need to, if it's a fraction, like if it's in parentheses, please put it there. And you're going to substitute a 2 in for the x, okay? X, 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 and x. Okay, so I'm going to substitute a 2 here, a 1 here, a 0 here, a -1 there, and a -2. Now this is easy to do. 1/4 to the second power. You just go 1/4 times 1/4. 1 times 1 is 1. 4 times 4 is 16. So that's 1/16. Now, if the exponent's negative, it's not -1/16. You need to reciprocate that to 16 over 1, which is the same as 16. Okay? Now 1/4 to the first is 1/4. Now when I make the exponent negative, it just reciprocates to positive. Okay, so that's going to be 4, and anything that's 0 is 1. Now bring those up here. We have 1/16, 1/4, 1, 4, and 16. Now remember, they all need to be multiplied by 2. Okay, because if I just graph that, I'm forgetting about the fact that the output is times by 2. So 1ABC 16 times 2, I get 1/8. Circle that. 1ABC 4 times 2, you get 1/2. 1 times 2 is 2, 4 times 2 is 8, 16 times 2 is 32. Now, where would it make most sense to start at, 1/8 or 32? You start at the more extreme end, which is 32. So you're going to start coordinating the points there. So -2, 32. So I go to -2, and then 32 is between the 30 and the 35. -1, 8, so -1 and then 8. 0, 2, so that's in here. Now with these fractions, all that's happening is you're getting close to the x line, but you're never crossing it. So when I have the negative outputs for the inputs for the x, the graph for y gets infinitely higher. Now when I do the positive outputs, all that happens is you get closer and closer to the 0. You never cross it. Okay, just get closer and closer in forever. Okay. Okay, that's that. Okay, now I'm going to do another graph. So we have y equals 1/2 times 4 to the x power. So again, that's going to be an exponential function. Those do not make lines. Okay. So you set up your input-output table. Just go 2, 1, 0, -1, -2. And just circle your power. So you have 4 to the x power. And you're going to do 5 inputs. And those inputs are 2, 1, 0, -1, -2. So 4 to the second power, well, that means 4 times 4, and that equals 16. So if the positive 2 is giving me 16, the negative 2 just reciprocates the 16, not to -16. Reciprocate means you flip it to 1/16. That's the reciprocation. That's how you reciprocate. 4 to the 1 is 4. 4 to the -1 is 1/4. Okay? Then you get 1. Now remember, these have to be multiplied by 1/2 at the end. So just 4 to the second, these inputs give me 16, 4, 1, 1/4, 1/16. Now you multiply them by 1/2. So that's 8. 4 times 1/2 is 2. 1 times 1/2 is 1/2. You're going to get 1/8 on the next one. And 1/16 times 1/2 gives me 1/32. Okay, now we'd want to start here, okay, because that's where I see the whole output. So 2, 8, so I go to right 2, up 8. It's going to be backwards from the last one. 1, 2, so right 1 up to 2. 0, half. Now with those last two, all you do now is get closer to the 0, okay, because those are less than 1. That's even smaller, okay. Okay, there you go. Never cross the middle. That middle line is something called the asymptote. It's called the limit that you can never cross. Now there's a bunch of crap here. You just have 9 and 10 to figure out. Find the fourth row to 81. That means what times what times what times what equals 81. Well, I'm relatively sure it's not 1. Okay. Is it 2? Nope. Is it 3? Yes, so that equals 3. Now, that's called a fractional exponent. It's also known as a rational exponent. Remember how this works. You make a root, and you take that 3, put it on bottom. The 125 goes inside. Then you put a parenthesis around it, and you put it to the power of 2. So, what times what times what, that's a third root. Now it's a third root instead of a fourth root, equals 125. Is it 1? No. 23? No. Nope. Is it 5? It is 5, but remember it's 5, but we still have 5 to the second power, so we need to take 5 times 5, and that's 25. So again, a fraction exponent means that that's a root, a third root of 125, and then a second power after we figure that out. Okay, and it's story problem time. We got 2. Now this no boxes, no tables on this, okay? The formula's right there. A bank client deposits $5,000 in a savings account that pays 3% interest compounded quarterly. Quarterly is 4 times a year. That means N equals 4. How much money will be in the account after 2 years? So P. P is your money that you deposit, okay? R, that's your percent as a decimal. And we already know that N equals 4, and then T is how many years that we have. Okay, so P is 5,000. R, you don't just put 3. You need to make your 3% a decimal. So once, twice, that's 0.03. And we already know it's 4, and T is your years, which equals 2. Okay? So A equals, so we replace P with 5,000. And then we put times, not plus. This means times right there. Then 1's always there. Plus, 1 stands for 100%. So R you took to put your 0.03 divided by your N, which is 4. Then you put your exponent, and you need to take your N, which is 4, times your T, which is 2. So a couple things I'm going to do here. I'm going to drop my 5,000, okay? Then I'm going to figure out what's in that parentheses and what's the exponent separately. Well, we know 4 times 2 is 8, right? Now, 1 plus 0.03 divided by 4, 1.0075 to the 8th power. Okay, and now you can solve it. Okay, so 5,000 times 1.0075 to the 8th power. I get $5,307.99. And that's compound interest. Okay, then the last one. The value of a car is $13,000. The car loses value at a rate of 15% per year. That means it goes down 15%. Approximate the value of the car if I decide to sell it in 10 years. Now, you want to use your units, the dollars and the years here, because it's not compound. X is years, Y is money, then per, dollars per year. Okay. there's no dollars per year. Instead, what you have is a percent per year, so minus 15%. So what that means is this is an exponential function. Just put expo. You need to find what your factor is. Okay. To find your factor, you take 100% and you minus 15%, and that's 85%. But you need to move the decimal once, twice. So the expo factor is 0.85. So now I make a table. Y is money, X is years, and we're just going to go 0, 1, 2 because it's per year. We don't have. There was an assignment where we like skipped years and had to take the exponent and divide it, but this is per year, so it's every single year. We have to find the value at 10 years. So we start at 13,000, and then what I do with this factor is I repeatedly multiply by 0.85. Okay, that's 11,050 times 0.85 again. 9,392 $9,392.50. And I need to find the money. Now, on an expo function, when I'm multiplying, we don't really make a line because it's not a line. It's one of those hook graphs, which is impossible to kind of figure out when you're doing a story problem. So you use this equation, a times b to the x power equals y. Okay. So a, b, and x. Okay. A is where the y starts. Okay. It's your initial money amount. Okay. So the A is 13,000. The B, okay, the B is your factor, 0.85. And then the X is your power that you're multiplying by, which is 10. Okay, and I'm going to write in words what these means right here. Okay. By the way, this is called a decay factor. It's a growth factor if you add it. But okay, so again, A is where the Y starts. Okay, where does Y start? Okay, B is your factor. Could be a growth or a decay factor. And of course, X is the number of years we have. Okay, and the Y is what we're solving for. Okay, so A, 13,000, B is 0.85 to the power, and then X is 10. Okay, so I solved that. Punched it into a calculator. So 13,000. And also, you don't, rather than write all this crap, you know that that's A, you know that that's B, okay? And then we'll replace the X with 10. So 13,000 times 0.85 to the power of 10. I got $2,559.37. Okay, so the percent means it's an exponent. You got to find your factor of multiplication. Same thing. Then you multiply by it every time. A times b to the x power. You know that that's A and that's B, but then 10 is going to replace the x. Okay, and you got to solve for the y.